The last lesson as the rates of reaction series is going to be actually very important for not just rates, but any experiments. We're going to talk about variables and how to talk about repeatable, reproducible results and explaining kind of those experimental long 6-mark questions. So first we need to consider different types of variable, their meanings. So categoric is quite rare example. Categoric just means a label, for example, large or medium. Continuous is like a number. So for example, continuous results will be volume, time, mass. So unlike, say, hair color, which is, say, brown or black, this is continuous. Now, these three are the most important in chemistry. Independent means the one that you change. Dependent means the one you measure. And control means the one you keep the same, to keep a fair test as such. But we don't say to keep a fair test. So it really depends on your reaction. Think for rates, if you're investigating one of them, keep everything else the same. So for example, if I'm investigating concentration of hydrochloric acid, just use the marble chips experiment, then you've got to keep everything else the same. So the type of acid needs to be the same. The volume of acid needs to be the same. The temperature, the surface area needs to be the same. Okay. One thing about concentration is that, say you're trying to dilute something, you could use 50 of HCl and 0 of water. That will have the most concentration. Then you could do 40 and 10, 30 and 20, 20 and 30, and 10 and 40. So as you go down, you'll get more dilute. Okay, so the total volume is kept constant, but you're changing the ratio of the HCl to the water to change the concentration. So you've got to use common sense. If you're investigating temperature, then obviously you'll have to keep the concentration and volume of acid the same, and the mass of the solid and the surface area of the solid the same. So that will come with exam practice, of course. And I do have a special lesson on required practicals. Not a special lesson, but I have a worksheet that kind of talks through some of the key practicals for AQA. So you can have a look there. There's 8 practicals. Now, what we must do today is look at the next things. So why do we repeat experiments? We normally repeat, we ignore anomalous results, which are ones that don't fit the pattern, and then we take an average with the results that are not anomalous. That reduces the effect of random errors, and it can make the experiment more repeatable. Now, we need to look at what does this repeatable actually mean. So let me just position more centrally. Okay, great. So repeatable and reproducible were introduced in the syllabus within the past kind of 5 years. So repeatable is when an experiment is repeated by the same person with the same method apparatus and he gets the same results. So repeatable means the same person is doing it and getting similar results. Reproducible means another person is doing it using different equipment and getting the same results. So repeatable, same person; reproducible, another person, different equipment. Together, these essentially make a reliable result. But in the past, they used to be called reliable. Now we call it repeatable and reproducible as separate bits. So pay close attention in the exam. They can ask you any of these. A fair test is when only the independent variable affects the dependent variable. So that means that the one you change is the one that has the effect. Everything else has to be controlled and kept the same. Then come these words: accuracy. Accuracy means how close you to the true value. So that's extremely important. Precision does not have to be accurate. So you could be really precise at getting the wrong result. A little bit like darts. The middle part of the dart is where you're trying to throw it. You could be really precise at getting it on the outer circle. Okay, so that's not accurate, but it's precise. So be careful. There's a difference between the two. Precise is how close the sets of repeat experiments are. Resolution is to do with the subdivision scale of your equipment. The smaller the scale divisions, the greater your resolution will be. So for example, to improve the resolution and even the accuracy of the experiment, you could use a more decimal place balance. And lastly, we need to look at errors. So random errors are caused by poor measurement. So that's when you measure the temperature wrong. Systematic errors is when the apparatus reads incorrectly by the same measurement each time. So that's to do with your apparatus. Systematic error is your apparatus being wrong. Random error is when you're wrong. Okay, you're just not measuring it correctly. Right, directly proportional. If someone asks you to describe a graph, and the graph happens to look like this, and you say as x increases, y increases, that's only one mark. Well, you have to say, if it goes through 0, 0, and it's a straight line, you have to say that x and y are directly proportional. So as you double x, y doubles. And then the word valid is the suitability of the experiment to investigate the question being asked. That's what valid means. Is it a valid result? Was the experiment suitable to the hypothesis? Okay, so that's that. And then one more little thing here. How do you measure uncertainty? So whenever measurement of a series of measurements are made, there's an uncertainty. So uncertainty around a single measurement. Every reading taken will have to have some uncertainty because the apparatus only has so much precision. So for example, when we do titrations, if you're using a burette, it will have an uncertainty value of 0.05, and that is because that is half of the scale division. So burette goes 22.1, 22.2. So what you do is you halve the 0.1. So that means the real measurement might be 0.05 above or 0.05 below. Which is why if you're using burette, you must always give your answers in 2 decimal places. So if you see 2 decimal places here, you must say 22.10 if you're doing a titration. If you're using a 2 decimal place balance, then that will be accurate to 0.01. So that means you could actually divide that by 2. So your uncertainty measurement will be plus or minus 0.005. Uncertainty around repeated measurements. So this was single measurement, this is repeated measurements. So if a set of measurements are taken and are repeated, then the uncertainty will be half the range around the mean. So for example, if you were collecting gas and you got these 5 results, clearly 67 is anomalous, so we exclude it. Then we take an average of the 4 numbers left and we get 46.5. Then you calculate the range, which is between 49 and 45, again ignoring the 67. That gives you a range of 5 seconds. Then you halve the range, which gives you 2.5 seconds. So then your uncertainty will be 46.5, the average, plus or minus the 2.5, which is half the range. This is unlikely to be examined, but it's just something to be aware of. Okay, that completes the experimental lesson. And you really just need to practice the questions to get used to the common answers, because in each year they would have tested the practicals you do in school. So for example, where you have the conical flask and you put in the bung on top with a delivery tube, there's obviously an error because if you add the solid to the acid, the carbonate to the acid, it'll start to fizz immediately. So you have to be really quick at closing. Either way, you're going to lose some gas. So that's one of the common errors that will result in less volume of gas being recorded. So whenever you also answer graph questions, so say you have a line of best fit, and there's a point here, you've got to consider, should this point be higher or lower? In this case, it should be higher up. So whatever the y-axis is, so for example, volume of gas was here and time was here. Why is the volume less than it should be? Well, maybe the person didn't put the bung quickly enough. Okay. Alternatively, if the value was up here, and we know that it should be down here, Why was there more gas collected? Or perhaps the guy used a higher concentration or a higher mass of solid. So you always have to link it. Don't just say the person measured it wrong. You've got to be really specific by looking at what should have been achieved. Okay, congratulations. That brings an end to the rates of reaction topic. So you can move on to the next one. Thank you.